All right, Algebra 2, moving on to 5 for dividing polynomials. Okay, how can you divide polynomials? That's our question for today. We're going to look at two methods. The first one is long division, and then the second one is synthetic. Okay, let me take you back a little bit to when you did long division back in elementary school. Okay, you set it up like this, and you said, okay, 21 doesn't go into 6, but it goes into 67. It goes in 3 times, so 3 times 21 was 63. Then we subtracted. You got 4. You brought down the next term. 21 goes into 42 twice. 2 times 21 is 42. You subtracted. You got 0 remainder. Done. Okay. Well, we're going to do a very similar thing here with our polynomials. And a little hint here is you want to divide the first term into the first term, and I'll show you what that means. Kind of similar to what we did here, how we took this into the first and then we had to go to the second. Let me show you how that's going to work. Let's go ahead and do a couple examples here. Okay. First one, what we want to look at is taking the first term and putting it into the first term. What do I multiply 2x by to get 6x squared? And that's going to be 3x. Right? Okay, so we multiply those two together. Let me do this. So we multiply 3x by 2x and we get 6x squared. Now you also got to multiply it by the 1, so we're going to get a plus 3x. Okay, now just like what we did in long division previously here, we subtracted. And when you subtract, what you end up doing here is you change the signs all the way across. Okay? That's the key right there, okay? Don't forget that step. We subtract. Now that's going to cancel. And 7x minus 3x is 4x. And I bring down my next term, just like we did with regular long division. Okay? Now I'm looking at what do I multiply 2x by to get 4x? That's 2, positive 2. And you notice I got my x's over my x's, my constants with my constants. 2 times 2x is 4x. 2 times 1 is 2. Then I'm going to subtract. So I'm going to change the signs all the way across. 0 remainder. So 2x plus 1 goes into 6x squared plus 7x plus 2, 3x plus 2. Okay? You could also look at it as factoring too. That times that's going to give you that. Okay, so we kind of found the factors there. Well, let's look at another example here. Okay, it's written out like this. Remember, whatever you're dividing by goes outside. That's your divisor. So I'm going to start off here. X into 4x squared. That's going to be a plus 4x. 4x times x is 4x squared. 4x times 5 is plus 20x. We're going to subtract, so I got to change the signs all the way across. That cancels out. I get 3x. I bring down my negative 16, minus 16. X times 3 gives me 3x. 3 times 5 is 15. I'm going to change my signs because I'm going to subtract. I end up with a negative 31. Okay, that's my remainder. When what you get down here, okay, after you subtract, when that degree is less than that, you're done. You can't go any further because you can't get x into 31. So I don't need the plus there either. So 4x plus 3 with a remainder of negative 31. So it didn't go in evenly. All right, but that's what it would look like there. That's long division. Okay, some of the problems can be a little long this way. That's just the way it is. If they ask you to long divide, that's what you got to do. Okay, the other where we're going to look at dividing is synthetic division. Okay. In synthetic division, we use the x minus a as the divisor by setting it equal to 0 and then solve for x. So we're not actually going to divide the whole x plus 2 in it. In this case here, it would just be a negative 2. So x cubed minus 14x plus 51x minus 54 divided by x plus 2. We set up synthetic division this way, and this is totally new to you. You haven't done this before. So since I got negative 2 for my x, that's what's going to go out here. That's what I'm going to divide by. And then I'm going to rewrite the coefficients. 1, negative 14, 51, negative 54. What I want to caution you here is notice I go exponents 3, 2, 1, 0, okay? So if you're missing, if I didn't have an x squared in here, I'd have to put a 0 in for the placeholder, okay? Don't forget that, okay? You'll see that in some of the examples we do. I'll remind you again. So once you've written down the coefficients, then bring down the first coefficient. You can see I brought down the 1. And then what you're going to do is you're going to multiply it here, okay? You're going to take the negative 2 times the 1, and you're going to write it right here, okay? And then you're going to add down. So we're going to add down this way. So we get negative 16. Then I'm going to multiply again. Negative 2 times negative 16. I'm just going to keep repeating this. I'm going to get 32. I'm going to add down. That's going to give me, what, 83 times 2. Where'd I go here? Okay, so I'm going to get a negative, what's that going to be, 166. And so I get a negative 210 here, okay? So, and then what you look at here, what you've got left is this. What does this mean down here, okay? Well, this right here is your remainder. You always start with the remainder. If it's a 0, that means you got no remainder. It went in evenly. And then I work up. That's my constant term. That's going to be the coefficient for my x. That's going to be the coefficient on x squared. And if I had another one, it'd be x cubed, and so on. So it would look like this. X plus 2 is what I divided in. And this is going to give me x squared minus 16x plus 83 with the remainder of negative 210. Whoops. Okay. Since it didn't go in evenly, I just kicked that right here. But I can rewrite this. There's my constant term, my negative 16x, my x squared, and so on. Okay, so that's the answer I'm looking at when you divide in this by x plus 2. Okay, we're going to look at more examples of that in the book. Here's another example from page 323. They give you the volume of a box as x cubed plus 7x squared minus 38x minus 240. And it tells you the width is x plus 5. Find the dimensions. So I'm going to use synthetic division here rather than long division. If I did long division here, this is the answer I would get. Doesn't matter which way, but this is a lot simpler. I'm going to take negative 5 in here. I write down my coefficients, 1, 7, negative 38, negative 240. I bring down the first coefficient, it's 1. Then I start multiplying and adding. Negative 5 times 1 is negative 5. Add them up, I get 2. 7 minus 5 is 2. Negative 5 times 2 is negative 10. Negative 38 plus a negative 10 is negative 48. Negative 5 times a negative 48 is positive 240. Negative 240 plus 240 is 0. So I got a 0 remainder. Negative 48 for a constant term, 2x, and an x squared. So x plus 5 times x squared plus 2x minus 48. There's no remainder, so I don't have to worry about it. And then I can factor this. Factors of 48 that differ by 2, 8, and 6. So there's my 3 dimensions for my box. My length, my width, and my height. I just don't know what x is. Okay? So that's what you get. Synthetic division. We'll look at a lot of this in class and look at a lot more examples of that. Things to remember. Write the coefficients down. If you're missing an exponent in here, like if it went from 3 to 1, make sure you put a 0 placeholder. Rewrite the coefficients in here. Take the opposite sign. Bring down the first term. Multiply. Stick it here. Add them up. Multiply. Stick it here. Add them up. Multiply. Stick it here. Add them up. And then it's always remainder, constant x, x squared, x cubed, however far you have to go. And those are the coefficients for each of them. Okay? A neat little thing that happens here, we're going to get into this more in a later section, the remainder theorem. Okay? If you're dividing a polynomial p of x, any one of these, that has a degree bigger than 1, by an x minus a here, okay, then your remainder is always p of a. What that means is, like here we had a remainder of negative 210. If I put negative 2, that's my a in this case, right? If I put that negative 2 in here for x, and I figured it out, you know, I cubed it and then squared it, multiplied by 4, and I figured that out, what p of with negative 2 would be if x was negative 2, I would get negative 210. Okay? It just works out that way. If I had taken my -5 and plugged it in for x here, I would have gotten 0 for a remainder because I got 0 there. That's what they're saying here. Okay, whatever you're dividing by, if you had plugged that in for the x into your function, you're going to get your remainder. Okay, it's kind of an interesting thing. So that's long division, and that's synthetic division. Next couple of days we'll be looking at both of those in class. All right, see you then.